Okay, good morning, grade 8. How are you doing? Hope you are fine. Today we're going to start a new lesson in geometry, chapter 6, lesson 1. Properties and attributes of polygons. All of you, of course, know and learn about polygons. Polygons have so many names according to the number of sides. But important thing that you have to know for polygons, that polygons is not an opened figure, and it's formed from sides. Like if I have here a circle is not a polygon because it is curved and all the polygons are formed from sides. Okay, if I have like this one, this is a figure formed from sides, but here it is opened. So I cannot call it polygon because all the polygons are formed from sides and they are all closed, not opened. Okay, girls? Okay, so let's read together. You have learned the definition of a polygon. Now you will learn about the parts of polygon and about ways to classify polygons. Each segment that forms a polygon is a side of the polygon. The common end point of two sides is a vertex. The common end point of two sides is called vertex, as you see here in the diagram. This is called side, and the blue point here is called vertex. The common end point of two sides is a vertex of the polygon. A segment that connects any two non-consecutive vertices is a diagonal. Okay, this green line here, this one is called a diagonal. Okay, let's classify the polygons according to their sides. If the number of sides is 3, so it is called triangle. 4, quadrilateral. 5, pentagon. 6, hexagon. 7, heptagon. 8, octagon. 9, nonagon. 10, decagon. 12, dodecan. N, which means whatever the number of sides is, I will call it anagon. Okay, girls? So, tell whether each figure is a polygon. If it is a polygon, name it by the number of sides. Okay, this one, yes, it is all sides and it is closed. So let's count. Here I have 1, 2, 3, 4, 5. It is 5 sides. 5 sides here is what? Pentagon. So it is polygon, yes, and it is pentagon. This one, no, this one is not a polygon. Of course, this one is not a polygon, okay, because it's formed from sides. Yes, it's formed from sides, but it should be a regular one. So it is not. This one, yes, it is a normal polygon. So let's count the number of sides. 1, 2, 3, 4, 5, 6, 7, 8. 8 is called octagon. 8 is called octagon. Okay, girls? 8 is called octagon. Okay. Here, tell whether each figure is a polygon. This one, and name it. This one is no, because it is opened. This one is no also because it has curved and it should be formed from sides. This one is yes, in the middle, yes, and its name is, let's count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, and 9 is called nonagon. Okay, girls? Okay. All the sides are congruent in an equilateral polygon. Equilateral polygon. All the sides are congruent in an equilateral polygon. All the angles are congruent in an equiangular polygon. A regular polygon is one that is both equilateral and equiangular. If a polygon is not regular, it is called irregular. So regular polygon is named for a polygon that has all its sides are equal and all its angles are equal. If all its angles are not equal and all its sides are not equal, so it is called irregular. Irregular. Okay, so I have regular polygon and irregular polygon. I have regular polygon and irregular polygon. Irregular means it is equilateral and equiangular. Equilateral and equiangular. Equilateral, all the sides are equal. Equiangular, all the angles are equal. Other than this, so it is called irregular polygon. Let's move to the second page. Okay. A polygon is concave if any part of a diagonal contains points in the exterior of the polygon. A polygon is called concave if any part of a diagonal contains points on the exterior of the polygon, like this one. I have a diagonal here. This diagonal is outside the polygon. Yes, I can have a diagonal outside the polygon. So in this case, it is called concave. If I have a diagonal outside the polygon, so it is called concave. The polygon is concave. If no diagonal contains points in the exterior, then the polygon is convex. Then the polygon is convex. A regular polygon is always convex. A regular polygon is always convex. Regular polygon. The regular polygon is equilateral and equiangular. All its sides are equal, all its angles are equal, and it is also convex. And it is also convex, like this one. Okay, girls? Tell whether each polygon is regular or irregular. Tell whether it is concave or convex. Okay, A. As you see here, each opposite sides or corresponding sides are equal, but not all the sides are equal. All the angles, yes, 90, 90, 90, 90. So it is equiangular. Is it equilateral? All the sides are equal? No. Every two opposite sides are equal, but the four sides are not equal. So it is not regular. It is not regular, called irregular. It is concave or convex. It is convex because I don't have a diagonal outside. And by your eyes, you can decide it is convex or concave. This one, as you see here, all the angles are equal. All, you see here, the sign of the angles here are all equal, and this dash, 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 dash here means that all the sides here are equal. So it is equilateral and it is equiangular, so it is regular. It is convex or concave, it is convex. It doesn't have a diagonal outside. This one, it is all the sides are equal and all the angles are equal. But I cannot call it regular. Why, teacher? It is equilateral and it is equiangular. All the sides are equal and all the angles are equal. No, it is concave. That's why I cannot call it regular. It is irregular and concave. You see, by time, your eyes will know what is the concave and what is the convex. Concave, always you have outside. The diagonals here, I can form a diagonal. Here I can form a diagonal. Here I can form a diagonal. Here I can form a diagonal. Okay, tell whether each polygon is regular or irregular. Tell whether it is concave or convex. This one, all the sides are equal, all the angles are equal, so it's equilateral and equiangular, so it is called regular, and all the regulars are convex, so I can write it here, regular and convex. What about this one? This one, of course, it is concave. It's regular or irregular. It is irregular. Okay, let me read the chat here. Yes, excellent, Tala. Your answer is correct. Excellent. Okay, let's move to the next section here. Okay. To find the sum of the interior angle measures of a convex polygon, draw all possible diagonals from one vertex of the polygon. Now, this section and this part, I want to know the total measure of all the angles. Like if I have here a triangle, I know that the measure of the three sides of the triangle is 180, right? Okay, if I have a quadrilateral, any four sides shape, the measure of the four angles is 360. I want to know the total measure of the angles of any polygon. Girls, back here in this part, this angle plus this angle plus this angle makes 180. This angle plus this angle plus this angle plus this angle makes 360. Okay, makes 360. So here I want to know the measure of angles of any polygon. I have a rule. What is the rule? To find the sum of the interior angle measures of a convex, draw all the possible diagonals from one vertex of the polygon. This creates a set of triangles. I want to create triangles. All the possible triangles inside the polygon. The sum of the angle measures of all the triangles equal the sum of the angle measure of the polygon. Like The first case here, I have triangle, one triangle. Okay, this case, the second one here, I have a polygon. When I draw here a line, I formed two triangles. I formed two triangles, this one and this one. I formed two triangles. And don't draw another one. So you tell me, teacher, no, I can form another. No, only like this. So the quadrilateral has two triangles. The pentagon, when I draw diagonals, I can form three triangles. The hexagon, when I draw diagonals, I formed four triangles. But why I'm doing this? To know the measure of the total angles inside each polygon. For example, here I have 180. Here I have 180. Here I have two triangles. Two triangles, so 2 multiplied by 180. Here I have three triangles. So 3 multiplied by 180. Here I have four triangles. So 4 multiplied by 180. When I multiply 2 by 180, I get 360. When I multiply 3 by 180, I get 540. When I multiply 4 by 180, I get 720. So this means that the total measure of the angles here and here and here and here and here is equal to 540. Okay, girls, here I have four triangles. 4 multiplied by 180, because each triangle has 180. The measure of three angles in each triangle is 180. So and here I have four triangles. So 4 multiplied by 180 is 720. So this means that this angle plus this one 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 is equal to 720. How I can do it here? Look to the table. Triangle. Number of sides is 3. Number of triangles is 1 triangle. So it is 1 multiplied by 180, 180. Quadrilateral. 4 sides. I have in the quadrilateral here 2 triangles. So 2 multiplied by 180, 360. Pentagon. I have 5 sides in the pentagon, 3 triangles. I formed here in the pentagon, I formed 3 triangles. 3 multiplied by 180 is 540. In the hexagon, I have 4 triangles. I formed inside it 4 triangles. So 4 multiplied by 180 is 720. So the total measure of all, the sum of interior angles measured, the sum of interior angle measured is 720. Nonagon, whatever the number of sides in the polygon, what I'm going to do? N is the number of sides. Number of triangles is n minus 2. Sum of interior angles is n minus 2 multiplied by 180. For example, if I have 10 here, 10 sides, a nonagon has 10 sides. So the number of sides will be 10. Number of triangles is n minus 2, which is 10 minus 2, which is 8. So it will be here n minus 2 multiplied by 180. It will be 8 multiplied by 180. So whatever the number of sides I have a rule to solve it. N is the number of sides. How many triangles it will be formed in this polygon? N minus 2. 10 minus 2 is 8. So 8 multiplied by 180. Okay, girls? So the sum of the interior angle measures of a convex polygon is n minus 2 multiplied by 180. N is the number of sides of the polygon. Okay. Okay, finding interior angle measures and sum in polygons. Find the sum of interior angle measures of a convex octagon. Octagon is how many? Let's go back to the table in the first page. Octagon is 8. Octagon is 8. Let me read the chat. Yes, excellent, Tala. Octagon is 8. So I will write here 8. Okay, so find the sum of interior angle measures of a convex octagon. What is the rule? N minus 8. N minus 8. N minus 2. N minus 2 and N is 8. So 8 minus 2 multiplied by 180 to get the sum of measures of the angles in the convex octagon. Okay, find the measure of each interior angle of a regular nonagon. Find the measure of each interior angle of a regular nonagon. They want the measure of each one. To get the measure of each one, I have to do the following steps. First, I want to get the sum of the whole of all the angles that I have. Nonagon means 9. What is the rule to get the measure of the sum of the interior angle measures? N minus 2 multiplied by 180. N minus 2 multiplied by 180 to get the sum of the interior angle measures. So N minus 2, it is 9 minus 2, so it is 7 multiplied by 180. So it is all 1260. So the sum of interior angle measures of the nonagon is 1260. I want to get each one. They mentioned here regular. Regular means that all the angles of the nonagon are equal. So when I divide 1260 by the number of angles I have, I will get each angle. The nonagon has 9 angles and 9 sides. 9 angles and 9 sides. So the sum of interior angle measures of all is 1260 divided by 9. 9 is all the sum of angles. 9. I have 9 angles. I have 9 angles. So when I divide the whole sum by 9, I will get the measure of each. Find the measure C. Find the measure of each interior angle of quadrilateral PQRS. Find the measure of each. Okay, girls. A here is the sum of the interior angle measures. But in B and C, I find the measure of each. When it's required to find the measure of each, first you have to get the sum of all, then you will divide. Okay, so here, quadrilateral means 4. Quadrilateral means what? 4. What is the rule? N minus 2. N minus 2 is what? 2. 2 multiplied by 180 is 360. So they want to get all the measures C and 3C and C and 3C. So C and 3C and C and 3C, they all are equal to 360. C and 3C and C and 3C, if I add them together, because all of them have the same variable, which is C, so I have 8C. When I divide both sides by 8, so C is equal to 45. So angle P and angle R are equal to C, and C is equal to 45. So angle P and angle R are equal to 45. Angle Q and angle S are 3C, and C is 45. So 3 multiplied by 45 is 135. So it is a kind of algebra because I have to get the value of the variable C, then I will substitute to find the angle. Okay, girls, here find the sum of the interior angle measures of a convex 15 gun. 15 gun means I will say 9 minus 2 multiplied by 180. Whatever the number that I have, it is easy for me to solve. 15 minus 2 multiplied by 180. So it is equal to 13 multiplied by 180. It is equal to 2340 degrees. Here is 3A. Find the measure of each interior angle of regular decagon. Let's go back. What is decagon? Decagon is 10. So 10 minus 2 is 8. I'm going to write the rule. N minus 2 multiplied by 180, which is 10 minus 2 multiplied by 180, which is 8 multiplied by 180, which is equal to 1440. But they want here to get each angle, and it is mentioned here it is regular, so each angles, all the angles are equal. So I'm going to divide 1440 by the number of angles. It is decagon. Decagon means 10. So each angle is equal to 144. Okay. The last part, I will give it to you fast before we finish. In the polygons below, an exterior angle has been measured at each vertex. Notice that in each case, the sum of the exterior angle measured is 360. 360 measure of the exterior angles are 360. What are the exterior angles? Angles that are outside the polygon. Angles that are outside the polygon, like this one, like this one, like this one. 147 plus 81 plus 132 are equal to 360. All the sum of exterior angle measure is 360. Here in this case, I have this one. Exterior angles are all the angles that are outside the polygon. Outside the polygon. This one, and this one. You see, girls, all the angles that are outside the polygon. So I have 43, I have 111, I have 41, I have 55, I have 110. All of them are outside the polygon. So all of them are equal to 360. So the rule here, the sum of the exterior angle measures one angle at each vertex of a convex is 360. Find the measure of each exterior angle of a regular hexagon. Regular, all its angles are equal. Hexagon is 6. So the hexagon has 6 sides and 6 vertices. Exterior is 360. And it has 6 angles. So 360 divided by 6. 360 divided by 6. Polygon exterior sum theorem. A regular hexagon has 6 angles, 6 exterior angles, so divide the sum by 6. So if a polygon has 4 angles, so it has 4 exterior angles. If it has 5 angles, so it has 5 exterior angles. If it has 9 angles, so it has 9 exterior angles. And the sum of all the exterior angles are 360. And the sum of all the exterior angles are 360. Find the value of A in polygon RSTUV. They want to find the value of A. So A is all in the exterior angles. So I will write 7A here. 7A plus 2A plus 3A plus 6A plus 2A is equal to 360. Since all the terms have A, so you can add them. So they are 20A. When you divide both sides by 20, so A is equal to 18. So they want to find the value of A. Only they want to find the value of A, not the value of each angle. Okay, girls, lesson of today is really so easy. It is a little bit long, but it is so easy and so interesting. I hope before you answer the homework that you will listen again to the lesson or read the rules before you answer. Please review the rules. Although they are so easy, no need to review them. You can answer directly, but review them. Okay, girls? Thank you so much for listening.